your name is Humera Nazneen. What's your full name, Humera?
Humera Nazni.
Okay, actually, I didn't know it and I wasn't taking your assignment. I thought this is a student from others batch and it is. I, today I didn't know that it was you. So when I saw your name for today's class, then I got to know, okay, your full name is Humera. Completed from here.
Ma'am, your voice is lagging.
What's the last thing that you have written?
Ma'am, your voice is lagging.
Humera, is it better? Please check.
Yes, ma'am, now it is.
Now it's better. Okay, I was asking what all have you written in the last class? Just check in your notebook. See, I'll revise quickly whatever we have done in our last class. We discussed angular displacements concept. That is from an initial point to a final point when the angle is swept. That is known as the angular displacement. Then we have the whole concept of angle swept by the radius vector here. Okay, angle swept by the radius vector means, see, let's say this is the starting point, and if the body goes like this, so total angle that has been formed, that is known as the angular displacement. And we also talked about that this is a rotational vector, means it is dependent on the axis of rotation. Then we have angular velocity. Angular velocity is basically rate of change of angular displacement. Okay, means how much angle is this angle getting swept with respect to time. In 1 second, what is the angle that is coming? So it's like the way we have velocity in case of kinematics. This is your angular velocity in case of rotational motion. So omega is equal to theta by t. This is what we have completed. Then we discussed when do you have to calculate time durations, average value, and using time instantaneous angular velocity. These two things we've already studied. One more thing we studied was the relationship between
Ma'am, is this chapter 4, laws of motion?
linear velocity, angular. We're studying. Okay, see, not just laws of motion. This is the circular motion that is present in different chapters. What I have done, I have taken all the circular motions portion together. Whatever is important in rotational motion, projectile motion, laws of motion, so all these things have been written together. Got it? So it's actually like your circular motion complete topic. Whatever is the part of laws of motion, that I'll tell you specifically. Okay?
Okay, ma'am. No, ma'am, actually, I missed that third chapter in the motion in a plane in the batch. So,
How?
no,
You?
that some classes I didn't attend.
Okay. So, do you have any exam, Humera?
No, ma'am, my exams have over yesterday only.
Okay. How did the physics exam go?
It was good.
It was good.
Yes.
Any feedback that you would like to give about the exam, in the sense what are the weak areas you could find, or what were the troubles, or what were the good parts, so that we can focus accordingly only? Tell me.
Like
Yeah.
in problem solving in some questions.
Some questions you had a trouble in solving the numericals.
Yes, ma'am.
Theory part you felt fine, Humera?
Yes, ma'am.
So, Humera, what we can do, circular motion, let's complete because this is now in the middle. So at least let us complete one portion. Then what we can do as per your wish, whatever you want. Then we can start with motion in a straight line, motion in a plane also, because the classes have been missed. How do you want to go about? Just tell me, because this is a one-to-one class. Whatever will be done will be according to you. I don't have to see other students think anything here. So you tell me, Umera, how do you want to go about with the syllabus and everything? Accordingly only I'll discuss. Right now I will suggest you, let's complete circular motion, that will complete chapter 4. And for motion in a plane we can have the next class, so that whatever motion in a plane portion is, that we can discuss. You tell me, how do you want?
Yes, ma'am. After this motion in the plane.
Motion in a plane you want to do, no? Okay. Just in case if you want any change here and there with the syllabus or anything, with any order of any chapter or anything, please just tell me in advance, man. Okay, so I will prepare you accordingly. It will be done up to you, according to you. So V is equal to R omega is the formula that we saw, R omega sine theta. Their angular velocity, then few numericals we saw based on this. And from the last class, we have to start with uniform circulation. Just give me a minute, Humera. Just give me a minute. Please wait. Yes, ma'am. Am I audible?
Yes, ma'am. Ma'am, I
Okay.
will come after 5 minutes. Actually, I have
Okay.
to go for.
Just let me know once you're back, okay?
Okay. Yes, ma'am.
Yes, ma'am. Regarding uniform circular motion, basically there are few things that we studied in the last classes. One is the linear velocity. See, linear velocity is tangent. Okay, this linear velocity will always be tangential to the surface like this. This will be the linear velocity. Remember, direction of linear velocity is always marked tangentially to the surface. This is fixed. Linear, because now see, you have already studied the linear velocity. We have already studied about the angular velocity. Now both of these things will be combined. So when we talk about the linear velocity, its direction is tangential because this is very helpful in many questions. Then here is the radius here. It's the radius over here. And see, in the center, it will have its axis where the angular velocity will be present. Now see, when we talk about the angular velocity, linear velocity's magnitude is constant. Means if it is, let's say, 3 meter per second at this edge. Here we have velocity is 3 meter per second. Here the velocity is 3 meter per second. Here also the velocity will be 3 meter per second only. Okay, means magnitude cannot change if you are saying that this is a uniform circular motion. For a motion to be called as a uniform circular path, it has to have all the velocities constant. Means no acceleration. Second is direction of linear velocity can change. Now, what's the reason for that? Simple reason to it is, see, direction is tangential. Now, every point will give you a different tangent. Every point will give you a different tangent. Okay, so that is direction of linear velocity can change. Third is the magnitude of angular velocity has to remain constant in direction of. See, angular velocity there has to be no change. If it is, let's say, 4 radian per second, so it will continuously remain 4 radian per second throughout. And direction also is constant, that is along the axis. Only one thing can change, that is the direction of this linear velocity. This directional part can change. Rest of these things have to be fixed. And when you see these things, then only you say, yes, a uniform circular motion is there. Okay, till here it's fine?
Yes, ma'am.
Okay. Next is rate of change of linear velocity. Now, this linear velocity that is coming in your circular motion, this is giving rise to different acceleration. Why? Rate of change of linear velocity is basically acceleration. Rate of change of velocity is acceleration. So what is tangential acceleration basically? Whenever the magnitude, two things are getting changed, two things can change, magnitude also, direction also. So when the magnitude is also changing, direction is also changing, you will have accelerations present in your system. So for the tangential acceleration, we have when the magnitude of linear velocity changes. Linear velocity changes. Then you get tangential acceleration represented as a t. Second is centripetal acceleration. That is when the direction of linear velocity changes. Linear velocity changes. Okay, when the direction of this changes, then you get centripetal acceleration. Now, what are these? These in detail, I'll tell you. Let me just tell you a little bit about both of these. See, tangential acceleration is basically rate of change of velocity. Means you say dv over dt. This we'll do again. Tangential acceleration, we'll be doing it again. This at is the symbol for tangential. acceleration. Okay, this is tangential acceleration. Just change in velocity by change in time. While centripetal acceleration is different. It is v square divided by r. This is the formula for it, where AC is the centripetal acceleration, v is the linear velocity, and r is the radius vector. This is the linear velocity and this is the radius vector. AC is equal to v square by r. Now, what's the direction of centripetal acceleration? Remember, this is directed always along the radius, always along the radius. And that too, it will point towards the center like this. This is your tangential acceleration's direction. Got it?
Yes.
So we'll see numericals also based on all of these things, but first you copy down each point and just text me you're done, then I'll scroll down, okay? Please.
Ma'am, in the diagram, what is that W is equals to?
W is equal to 4 radian per second. RAD. Okay, look, this says a body is moving on a circular track with velocity of 10 meter per second. Radius of the track is 2 meter. Calculate the angular velocity and centripetal acceleration. See, the velocity is given as 10 meter per second. Radius of the track is 2 meter. You have to calculate the angular velocity, centripetal acceleration. Angular velocity, see, directly in the first part, we have to calculate what's this angular velocity. So V is equal to omega R is the formula. From here, omega will be equal to V divided by R. Now V is 10, R is 2, that becomes 5 radian per second. Okay, so formula based question, omega V is equal to omega R. Next is centripetal acceleration. For the centripetal acceleration, the formula is simply V square by R. So V is 10 into 10 by R is 2. So this becomes 5. That is 50. See, this is centripetal acceleration. Its unit will be meter per second square. We won't put radian per second square. Radian will come only when we'll have the angular acceleration. In cases of centripetal acceleration, we won't be including the radian per second because see, that's not a rotational component. So centripetal acceleration will be square by r, that is 100 by 2, which is 50 meter per second square, while the angular velocity is 5 radian per second. Easy formula based question. Have you got it?
Yes, ma'am. Ma'am,
Okay
can
then.
you explain that why we are not taking radian per second?
Radian per second. See, here we have, whenever we have acceleration, we'll be talking about two accelerations, tangential acceleration and the centripetal acceleration. All of these have the unit as meter per second square. Now, reason is that all these are due to the linear velocity, and linear component will have meter per second. Linear will always have meter per second square. As soon as you will consider a rotational velocity, that is rotational angular acceleration will come, then you will definitely have radian per second square. Right now we have this as our parent formula, velocity. From there we are deriving the AT and EC. So they have their parent origin from the linear one, that's a meter per second square, while angular is completely based on rotational, so that's why radian per second square. Fine.
Yes, ma'am.
Okay, note down this question, then we will discuss non-uniform circular motion and few things more we have to study. First, write it. See, for the non-uniform circular motion, non-uniform means if the magnitude of the linear velocity is variable, you get tangential acceleration. Okay. If the direction of the linear velocity is variable, you get centripetal acceleration. If the magnitude of the angular velocity is variable, you will get angular acceleration, alpha, that we've already studied in the last class. And if you see the direction of the angular velocity is constant, see, then you won't have any acceleration. Okay. So magnitude of V, if it is variable, we'll get tangential acceleration. Okay. Direction, then centripetal. Angular, then angular acceleration. So these are the three accelerations that we have studied. And I'll be discussing tangential again because that time I didn't discuss it in detail. So rate of change of magnitude of the linear velocity when we talk about tangential acceleration will be dv over dt. Or in fact, Humera, you can say this is delta v over delta t. Okay, this is the change in velocity by the change in time. Change in velocity by the change in time. This also you can use change in velocity by the change in time. Then SI unit is meter per second square. Why? Because this is arising from the linear component. Okay, so since this is arising from the linear component, you will have the meter per second square unit only. You won't use radian because that's not related to your rotation. Then direction is tangential to the circular path. This is the circular path. This is the velocity and this is tangential to it. So rate of change of magnitude, you can use delta V over delta T also, dV over dt also. Now, angular acceleration, see, angular acceleration we haven't discussed. Let me discuss that. Angular acceleration is represented by the symbol alpha. Alpha means change in angular velocity by the change in time. See, this is the angular acceleration. This is the angular velocity. And this is the time. Okay, so you can use, if you know, if you see that the angular velocity's duration is given. So similarly, like we discussed for the velocity, here also you'll do the same thing. If time duration is given, then alpha is equal to delta omega over delta t. And if time instant is given, then alpha is equal to d omega over dt. D omega over dt means you will have to differentiate them. This is very important, Humera, for you to understand. When you use the time duration, when you use the average one, this is the average one. This will give us the average one. When we will have a change, a particular duration will be there, a change in the time will be there, like 2 seconds to 4 seconds, 5 seconds to 8 seconds, like this. And when you have a time instant, a very particular small time instant is given, then you differentiate it basically. We'll practice numericals based on this. Okay, first write down these from here, write it from here. Have you understood, Humera, till here? Tangential, centripetal, and angular.
Yes, ma'am. Ma'am, what is
Tangential is
angular
the change one.
velocity?
Angular velocity, rate of change of angular displacement. Were you there in the last class, Humera?
No, ma'am.
Okay, see, angular, for then just copy this angular velocity is just this much portion. Basically, see, angular displacement means when the angle is swept by the body. This is known as angular displacement. And when this is divided by time, when this changes with time, that is called as angular velocity, which is theta by t. Means the way you have linear velocity, this is the rotational velocity, rotational analog of the velocity. Okay.
Okay.
Or I can share the notes also with you, or take the video lecture for the last class.
Okay.
Okay, see, Humera, this says linear velocity of a body changes from 10 meter per second to 30 meter per second.